Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to start with our departure sums. We are going to continue with them. So previously we have done the first 10 departure sums from Oxford Gen Nav. Today we are going to do the remaining sums. I hope you have understood very well the first 10 sums that we have done before. So keep practicing them. It will be very good practice. This Oxford sums, if you know them, you can solve any other departure sum from R.K. Bali or even Keaton Williams. So let's continue with our departure sum. So the first question for today is question number 11. Aircraft starts at position 4 degree 10 minutes south for and 178 degree 22 minutes west and goes true north for 2950 nautical miles. After that, it turns 90-degree right, correction left, and maintains a track for 314 kilometers. What is the final position? So let's draw this. So aircraft is starting from here at position A. It goes north direction, okay, for a distance of 2950 miles. Its coordinates are 4 degree 10 minutes south and 178 degree 22 minutes west. 178 degree 22 minutes west. Okay, 178 degree 22 minutes west. From here, it goes left, okay, for 314 kilometers. From this point, it flies left direction. It takes a left turn and goes that way. For how many distance? 314 kilometers. Now this distance is in nautical mile, that is in kilometer. So convert kilometer into mile. So we know one nautical mile is 1.85 kilometer. Okay. So 314 kilometers will be how many nautical miles? So cross multiply 314 divided by 1.85. That is equivalent to a nautical mile of 170, approximately 170 nautical miles. Okay, so now we have to find the final position or coordinates of this destination. Now look at this point. We have started from latitude 4 degree 10 minutes south. Now when we go fly above, when we cross other latitudes that come across our way, the value of a latitude will go on increasing. Okay, so as this aircraft flies northerly direction, it will fly across many other latitudes. Okay, it will cross many latitudes, but it will fly along the same longitude or same meridian of 178 degree 22 minutes west. That won't change. What will change is that its initial latitude 4 degree 10 minutes south will change when it goes to its final position over here. And when you travel along a particular meridian between different latitudes, you are actually flying a great circle track. I have said this many times. So this great circle distance, okay, this great circle distance from A up to this point is how much? D lat in degrees into 60. So great circle distance is 2950. D lat I don't know because I know the initial latitude. This final latitude I don't know. We will find out that into 60. D lat is equal to 2950 divided by 60. So D lat will be equal to 49 degree 10 minutes. In what direction? Northerly direction. So N. So this is your 4 degree 10 minutes south. When you go above, your latitude should increase. It will increase by what latitude? by a d-lat of 449 degree 10 minutes north. So new latitude will be equal to initial at south plus 49 degree 10 minutes. So let's see this. This is your equator. Let's say this is your earth. Okay, this is your earth. Over here is your equator 0 degree. Here is your latitude, initial latitude 4 degree 10 minutes south. So from here you will come north. You will cover a distance of 4 degree 10 minutes south. After reaching equator you will cover another distance, remaining distance. Okay, so 49 degree out of total latitude of 49 degree 10 minutes, when you cover 4 degree 10 minutes in coming to the equator, 45 degree leads. So when you fly north, you will come to a latitude of 45 degree north. Okay, so now as you can see, 45 degree plus 4 degree 10 minutes will give you a total distance of difference between latitude of 49 degree 10 minutes. Okay, so since our initial location was in the southern hemisphere, a part of total difference in latitude was spent in coming from south to equator, and then remaining part from equator to another latitude. So our new latitude is 45 degree north. 4 degree 10 minutes south, our new latitude is 45 degree north. 45 degree north. Okay, next. Now let's go to next slide. So next point they say from, just a second. From this point 45 degree north, we are going left for another 170 miles. Now this is your latitude 45 degree north, but what will be the longitude of this point? It will be the same as 178 degree, 178 degree 22 minutes west. The longitude will be the same. Now when you come to a new position, when traveling westerly, you will arrive at a new position. The latitude of that position will be the same as this latitude, which is 45 degree north. Correct? Because when traveling straight line to the left hand side, you are not changing latitude. You are not going above or below, up or down. So latitude is going to remain the same. What will change is that this meridian, 178 degree 22 minutes west meridian, will be changed. Okay, so when you go that side, that is when you fly westerly heading, there will be you will arrive at a new longitude, and that, so this will be Ramline distance. So when you travel across a particular along a latitude between two different meridians, that is your Ramline track. So let's write here Ramline distance equals to d log in minutes into cos of latitude, into cos of latitude. So distance given to us is 170. D long I don't know because I only know one longitude, into cos of 45 degree north. So D long will be equal to 170 divided by cos 45, which is equal to 240 minutes, or divided by 60, that will give you 4 that will give you, so 170 equals to d long in minutes. ठीक है, 170 equals to d long in minutes into cos 45. So d long in minutes equals to cross multiply 170 divided by cos 45, which is equal to 240 minutes of 4 degree. So your new longitude will be 178 degree 22 minutes west. When you go there, the longitude will be different. So let's plot it. North 0, 180 east, and west 90 east, 90 west. So our initial longitude is 178.22. 178.22 minutes west. Now you're going westerly. Westerly directions are anti-clockwise. Okay. So this d long is how much? This d long is 180 minus 178 degree. 1 degree 38 minutes. Okay. So out of total d long of 4 degree, when we subtract 1 degree 38 minutes, we will be left with 2 degree 22 minutes. So that means remaining part 2 degree 22 minutes will be spent when coming from 180 degree anti-meridian to the eastern hemisphere. So we will subtract 180 minus 2 degree 22 minutes will give me 177 degree 38 minutes. So our new longitude will be 177 degree, 177 degree 38 minutes. Okay. So out of the total d long between two longitudes of 4 degree, 1 degree 38 minutes were traveled. We crossed from going from 178 to 180. Now out of this, we have subtracted that much from total. This much distance is remaining in angular distance. Now this much angular distance will be covered when you go when you continue traveling westerly. So and why you have subtracted that from 180? Because as you continue travel westerly, your longitudes will decrease. 180 degree east, 179 east, 180 east, 170 east, 160, 150, so on and so forth. It will go on decreasing as you go anti-clockwise. Okay, that's why I subtracted 2 degree 22 minutes d long from 180 longitude to get a final longitude of 177 degree 38 minutes. So this is the answer. So latitude I found out 45 north and the longitude is 177 degree 38 minutes east. Okay, we have crossed this anti-meridian and now we have entered the eastern hemisphere. And so new longitude is 177 degree 38 minutes east. 177 degree 38 minutes east. Okay, so correct option will be option number delta. 177 degree 38 minutes east, 45 minutes 45 degree north. So a quick recap, draw the diagram and then the basics. You should know the basics of great circle and drum line very nicely. Location A is at a latitude. When we go north, we cross many latitudes and arrive at a final latitude. That latitude will be more than latitude of A, because when we go up up on the earth in the upward direction towards north pole, latitudes go on increasing. So if this is 4 degree 10 minutes south, by a d-lat of 49 by a d-lat of 49 degree 10 minutes of difference, our new latitude has become 45 degree north. How? Initial latitude was in the southern hemisphere. So out of the total difference, 4 degree 10 minutes was spent across or traveled from going from initial latitude to equator. From equator to new latitude, remaining distance of 45 degree was remaining. So that from 0 to 45 is your remaining angular distance. Okay, so your new latitude has become 45 degree north. Okay, from there we have gone westerly direction, and since the latitude has remained the same, okay, our final destination has also the same latitude. What will change is the longitude, because for a rhumb line longitudes change, latitude remains the same. For a great circle latitudes change, meridian remains the same. So once we find this great circle new latitude, using rhumb line we will find the new longitude using the formula. So d long I found, plot the diagram, check the direction in which you are going. Okay, in this you can see, if this is northerly direction, taking a left turn 90 degree, that will be a westerly direction. All westerly directions are anti-clockwise, so I have drawn this black arrow, and therefore I know my new final destination will be somewhat to the right hand side of this initial or departure airport, and therefore by a d long, total d long was how much? 4 degree. Okay, total d long was 4 degree. Out of that 4 degree, 1 degree 38 minutes were traveled from initial position to 180 degree anti-meridian, and remaining d long was traveled from 180 degree anti-meridian to a final destination. So this is how you will have to divide a total d long into two parts. If and only if the locations, departure and destination, are in different hemispheres. Like we saw in this case, for latitude, one was in south, one was in north. So we had to divide this 49 degree 10 minutes into 45 degree and remaining 4 degree 10 minutes. Same thing here, for longitude, total 4 degree were divided into 1 degree 38 minutes and another 2 degree 22 minutes. So this is how division happens if both locations are in different hemispheres. If they are in same hemispheres, you will have to directly subtract that difference from the initial latitude or longitude. Let's go to question number 12. Aircraft is at position 50 degree north 6 east. It travels south. So let's draw this. It travels south. Then it travels east. Then it travels north. And then it travels again west. What is final position of aircraft relative to the starting point? So A was a starting point. So A was a starting point. D becomes our ending point. So we have to find the relative direction. So with respect to A, is point D located to its easterly direction, or to the north of it, or to the west of it, or to the south of it? So we don't know. This is a rough diagram. So we will see what the relative direction is. So let's draw systematically. This is a location A. First we go south to B. And that distance is 300 miles. Location of A is 50 north 6 east. So let's tackle one route step by step. A to B, you're going south. When you go south, you travel across latitudes. So the latitude of B will definitely be something new. Longitude will remain the same. So let's apply great circle formula. It's d lat into 60. So 300 is equal to d lat into 60. D lat equals to 300 divided by 60, which is 5 degree. So our new latitude will be, when you go southerly direction, in the south direction, your latitudes decrease in value. They reduce in value or decrease. So 50 north will become 45 north. It will become 45. It will become 45 north. Okay, why? The difference between latitude is, as we saw here, is 5 degree. D lat is 5 degree. Let's go to next point. When you go 300 nautical mile east, okay, so from point B you are going easterly direction to point C for another 300 miles. Now when you go from point B to point C, this will be a easterly direction. So east west directions are rum lines. So in this case, your latitude will remain the same, 45 north, but now your longitude will be something else. So let's apply that formula. Rum line distance is equal to d long in minutes into cos lat. So rum line distance is 300, d long in minutes into cos of 45. So d long in minutes, 300 by cos 45. So d long in minutes is equal to 300 divided by cos 45 is equal to 424 minutes. Therefore, d log will be equal to, in degrees, it will be equivalent to 424 divided by 67 degree 4 minutes. Okay. So one answer is in minutes, another is in degree. So now here we will have to stop because we have initial longitude 6 degree east. We can find new longitude, that is okay. But we are going to check here. We will stop. We will go to another route, that is a third route. Why I am going to stop here, you will come to know later. So our third route is, it travels 300 nautical miles northerly. So delta for 300 miles northerly. Now what will be the same? The so as we go northerly direction, this latitude of 45 north at point C will change to a new latitude, and that will be more than 45 because as you climb up, your latitudes increase. As you go northerly direction, your latitudes increase. So again we will apply great circle. D lat into 60, 300 into D lat into 60, D lat is equal to 5 degree. D lat is equal to 5 degree. So our new latitude will be 45 plus 5, which is 50 degree north. Our new latitude will be 50 degree north. Now if this is 50 degree north, so next route is, we again take 300 nautical miles in the westerly direction. So that means again 300 nautical mile in the westerly direction. So in the westerly direction. So again the latitude of final position, that is E, will be the same, that is 50 north. Now why I have stretched this point up to that point, not up to here? Because I will take a new slide. If you know the concept well, If you know the concept well, if this is your earth, all your meridians converge at the north pole and south pole. Okay, they converge at the north pole and south pole. So let's take one particular latitude, 10 degree north. So the difference between two longitudes at this two here will be this much. When you go to a higher latitude, let's say 40 degree north, the same distance between these two longitudes will decrease. See, here it was this much, here it has decreased. Again, when you go up higher up the latitude, the longitudinal distance will decrease. Okay, the difference between two longitude, the distance will decrease. The d long will remain the same, but the distance will keep on decreasing. So that's why, let's come to this. At 45 degree north, if the distance between two longitude is this much, when you go to a higher latitude, so when you go to higher latitude, what happens? The distance decreases. So same 300 nautical mile at 45 degree north, when you go to a higher latitude, will not be this much, it will be more than that. Okay, so if this is 300 nautical mile here, so this will not be equivalent to a 300 miles distance. This will be somewhat 250, let's say, because this distance is going to be less than this. Okay, so to cover the same 300 over here at this latitude, we will have to fly an extra 50 outside, extra 50 outside. So that's why I have drawn 300 extra outside. Okay, so 50 degree north is fixed. Now let's find out the longitude. So let's apply Rumline formula. So Rumline distance is equal to d long into cos of lat. So distance is 300, that I know. Now d long. The d long between these two longitude is going to be the same between these two because both are same. So what we found d long here between them, 424 minutes. So I'm going to write that here. So that's why that is easy. So Rumline distance is d long into cos of latitude. So distance is 300. D long you do not know because this d long and this d long are same, but a new longitude is new longitude. So this d long will not be equal to that d long because we have traveled to a new longitude now into cos of 50. So d long is equal to what is 300 divided by cos 50. So that is equal to 500, that is equal to, so Rumline distance d long into cos lat 300 d long into cos 50. So d long equals to cos 50 divided by, sorry, correction, 300 divided by, so 300 divided by cos 50 is 466 minutes, or in degrees it is 7 degree 45 minutes. Okay, 7 degree 45 minutes. Now we know this initial latitude is 50 north. Initial longitude will be how much? So let's complete this part. Now here why I stop is because this d long will not be equal to this much d long, because that is the new longitude. So now here let's come to part 2. Initial longitude was 6 degrees. When you go easterly direction, your longitudes will increase. So new longitude will be at C will be 6 degree east longitude plus the difference. Since you are going easterly, the longitudes will keep increasing. 6, 7, 8, 9, 7 degree 4 minutes. So that is 13 degree 4 minutes easterly longitude. So longitude at C is 13 degree 4 minutes east. So this will be longitude 13 degree 4 minutes easterly longitude. Same longitude. So now here we have initial longitude. We have the total difference in longitude from initial to final, 7 degree 45 minutes. So now when we go westerly direction, what happens to our longitudes? They decrease. Okay. So 13 will become 12, 11, 10, 9, so on and so forth. So our new longitude will be 13 degree 4 minutes minus 7 degree 45 minutes. 7 degree 45 minutes. So do it in your scientific calculator. 13 degree 4 minutes minus 7 degree 45 minutes, that is equal to how much? So 13 degree 4 minutes minus 7 degree 45 minutes equals to 5 degree 19 minutes. So new longitude E equals to 13 degree 4 minutes minus 7 degree 45 minutes, that is equal to 5 degree 19 minutes. Still we are in the eastern hemisphere because it is 5 degree 19 minutes east. We have not crossed 0 degree. The difference is small. Okay. So first we plotted, this was a step 1, step 2, step 3, this was a step 4. And then finally we got new longitude 5 degree 19 minutes easterly longitude. So I hope you have understood this sum. So going back, we drew a left rough diagram, then we drew a proper diagram, go step by step, A to B, B to C, C to D, D to E. Now why is E right to the left of A is because as we go up in the, as we on the earth, due to the convergency of the meridians, the difference between two longitudes, the distance between two longitude at particular latitude is if it's x, when we go to a higher latitude, because of convergency, the distance between the same two longitudes will decrease and it will be less than x. It will be less than x. Again, you go higher up, it will be more and more less than x. Okay, due to the convergency. So that's why if this is 300 nautical mile here, the distance between these two longitude is 300 miles here. When you go to a higher latitude, the same 300 nautical mile will be this much. Okay, this extra. So you will end up going to a new longitude. You will end up reaching a new longitude. Okay, so that's why we drew E on that side of A because of that logic. Okay, so remember this. Pause this video, write this sum twice, look at the sum, just copy this sum twice, and then third time do it on your own. Okay, now the final question is, what is the final position relative to starting point? Now our starting point was A and the final position is E. So E is to the west hand side of A or left hand side of A. So correct option will be option number C. So with this we will stop here. We will do the remaining sums in the next departure solved sums video. So do come in that video, don't miss it. For not missing it, you should subscribe to this channel, so whenever I upload this video or that video, you get the notification. Hit the like button and also share this video with everyone. Keep learning. All the best.